This question is related to cycloalkanes. When alkane from a crude oil are reformed, reforming means converting the alkane into branch or a cyclic compound. We call that process as a reforming. So write equation for reforming of hexane into cyclohexane using a skeletal formula for organic compounds. So how alkane, like with such as hexane, can be converted into cyclohexane. So cyclic compounds, cyclic alkanes have the same general formula as alkenes. So when we complete a product, so hex means 6 carbon atoms should be there. So the skeletal formula of hexane, 1, 2, 3, 4, 5, 6. And that form a cyclic hexane, so 1, 2, 3, 4, 5, and 6. And there is no end because a cyclic compound. Then the hydrogen, 2 hydrogen must be removed from this. So we'll write H2 so that the 2 carbon can link with each other. Then in part B, the skeletal formula of a cycloalkane D is shown. So there's a cycloalkane D, the skeletal formula is shown. Give the name of D. So we should start numbering. Numbering should start from a nearest branch. So when we count, like if I consider this as one, first carbon, then second, third, fourth, and fifth. Why I did not count other way around? Because if I count other way around, 1, 2, 3, and 4, so fourth position, we have the second branch. But if I count here clockwise, 1, 2, 3, and 4, 5, so first position and the third position, we have a branch. So the name of this compound and which branch is there, because one carbon in the branch, so it is 1, 3. First position and third position, we have a branch, and we call that as dimethyl because identical branches are there, so 2 methyl groups. And now, how many carbon atoms are there? 1, 2, 3, 4, 5. So for 5, because it's a cyclic compound, so we say cyclo. And for 5, we call that as pent because of 5 and N, they all have a single bond. So it is 1,3-dimethyl cyclopentane. Then give a molecular formula of D. So what will be the molecular formula of D? You can count, like example, this will have 2 hydrogen, this will have 1. You can count in terms of carbon and hydrogen, or remember the general formula of cycloalkanes or cyclic alkane is same as alkene. The number of the hydrogen will always be twice as compared to number of carbon. So if I count the number of the carbon directly, I can find the hydrogens. So how many? 5 already we counted. So 6 and 7. So it will be C7. If C7, then H, how many hydrogens should be there? H should be 14 because the number of the hydrogen are always twice as compared to number of carbon atoms. In part C, there are 4 structural isomers of C6H12. So cyclic alkanes are there C6H12 with a ring of a 4 carbon. One of these isomer is shown in the first box. We have to draw a skeletal formula of the other 3 isomers. So what we can do, we can change the position of a branch here. Like here, first and second, we have a branch. Then what we can do, we can simply change the position of a branch. We can make a branch with first and second. First and second is already there. So we can make a branch with first and third. Like this will be first and then third. Then I cannot make a branch here. Why I cannot make branch? Because that will also be 1 and 2. Because when we count, we should always count from a nearest branch or a functional group. So this will be 2. This is also already 1, 2. Then what else we can do? We might, here we have like methyl groups are attached. Maybe ethyl group is there. If the ethyl group is attached to this, so 2 carbon atoms will be there. or maybe the two branches might be attached with a, so this we cannot draw. This will be same as the first one. So we will change, maybe ethyl group is attached, or maybe what is the possibility? Two branches are attached with the same carbon. So these are the four different isomers of the cyclic alkane. Then a cycloalkane E has a molar mass of 126. Reduce the molecular formula. How we can reduce the molecular formula? See, it is CN. The general formula of cyclic alkane is same as alkene. So CnH2n. That is the general formula of alkene. Same as the general formula for cyclic alkanes. So the number of the hydrogen are always twice as compared to number of carbon. And the total mass is equals to 126. So I can say carbon is 12 and n carbons, so 12n plus hydrogen is 1 and multiply by 2, 2n is equals to 126. So it will be 14n is equals to 126. N is multiplied, other side will be divided, so it will be 126 divided by 14. So 126 divided by 14, that will give us a value of n, so n is equals to 9. So if n is equals to 9, what is the formula of the cyclic alkane? So it will be C9NH18. This part, a sample of a gaseous cyclopentane, which is having a volume of 25 cm cube, is mixed with 250 cm cube excess of oxygen. The mixture is ignited, only the gaseous products were formed. Calculate the volume of a gas remained after reaction. So basically it will be unreacted oxygen and the formed carbon dioxide and water vapors. And ratio of the moles is same as the ratio of the volumes. As you can see, we always take a limiting reagent. So first we'll find how much oxygen will be unreacted. So the ratio is C5H10 to oxygen, the ratio is 2:15. So if we have 25 cm cube, how much will be there? X. So it will be 25 into 15 divided by 2. So how much it reacts? Oxygen reacted is 187.5. That is how much oxygen react. But we want to find how much gas remain. So unreacted oxygen will be 250 minus 187.5. So amount of oxygen which is left, it is 62.5. So this is one thing. That is amount of oxygen. Then we'll find how much carbon dioxide will be formed. So we'll take a ratio again from a limiting reagent to the product. The ratio is 2:10. So 1:5 we can say. So if we have 25 cm cube, this will be X. Cross multiply. So 250, 25 into 10 is 250 divided by 2. That's equal to 125. So 125 cm cube of carbon dioxide will be formed. And same thing, we'll take a ratio between C5H10 and water H2O. The ratio between them is also 2:10. So if we have 25 cm cube of cyclopentane, X cm cube will be there. So again, it is 125. So the total volume of a gas which is left, 62.5 is the unreacted oxygen, 125 is a formed carbon dioxide, and 125. We take a ratio of the moles as ratio of the, because the ratio of the moles is always same as ratio of the volume. But remember, for gases, as they mentioned, all are in the gaseous state. That's why we are taking the ratio. So 250 plus 62.5. So the total volume of a gas which is left at the end of this reaction is 312.5 cm cube, which include the unreacted oxygen and the formed carbon dioxide and water. In this part, if cyclobutane, which is C4H8, react with the chlorine in the sunlight. Name the mechanism and the type of reaction that occur. So whenever we have alkanes are reacting with halogens, so what they undergo, they will undergo free radical substitution reaction. So mechanism is a free radical. And the type is substitution. Then complete equation for initiation. In an initiation step, what happened? A free radical are produced. So half arrows will draw because both chlorine will take their electron back. So it will produce two chlorine free radical. Write equation for propagation of steps for a chlorobutane. C4H8 is a formula for chlorobutane, and curly arrows and state symbols are not required. Like you don't have to show curly arrows and state symbols. So what will be the equation here? We have cyclobutane, which is C4NH8. So C4H8 plus chlorine radical will be there. I'm writing it here, C4H8 plus chlorine radical. As a result, what it produces? It will produce C4H7 radical plus HCl. And then this C4H7 radical react with a chlorine molecule. As a result, it will produce C4H7Cl plus chlorine radical. So this is what happened in a propagation step. Then the last one, basically what happened in a termination, if there's a termination step. Then all the free radicals combine with each other to give molecule. A small amount of a hydrocarbon formed in this reaction deduce a skeletal formula and justify. So what will be the hydrocarbon which is formed? Basically, this is free radical C4H7 combined with another C4H7. As a result, it will produce a compound, like two rings will be there. C4H7 cyclic or a cyclobutyl radicals will join together. The skeletal formula for product. Look, this was a cyclobutane. So this cyclobutane, when it combined with another cyclobutane, because it is C4H7 radical combined with another C4H7 radical. As a result, it will produce C8 and H14 will be there. So C8 and H14, basically like one ring combined with another ring. So this will be the skeletal formula for product. So this is one and this one is the other. And justification is there that the butyl radical, cyclobutyl radical combine with each other. When two cyclobutyl combine with each other, as a result, they will produce a molecule which will have two rings are there or two cycles are there.